Okay, good morning. Alright, so so I got just an FYI, I graded all your midterm exams, and so you should see a grade on Blackboard for your midterm 1, and then I also posted solutions for the midterm 1 exam. Okay, so my solutions are right there, and so double check your grade, look at the solutions if you missed anything, and let me know if you have any questions about the exam. So let me just post that, and then we'll move on to today's material.
How do we view our exam?
How do you view what?
Our exam, like you said check it, so how do we view our individual exams?
Oh, so I mean, it's just the exam you sent, like the one you sent me? You know the one?
Oh, okay. My bad. Sorry, wrong class.
Yeah. Yeah, I don't have them like edited. There's no comments or anything, but yeah. So you can see if you missed any points, you can see what hopefully what's correct in the solutions. But did you have a specific question about the exam?
No. My bad. Early in the morning.
Okay. Okay, so midterm 1 grades are posted on Blackboard, and then midterm 1 solutions are posted on Blackboard. And so overall, you guys did pretty well. So the scores were fairly high, and it looked like most students understood most of the material. But if there were any questions, let me know. So did anybody have any questions about the midterm 1? If there are, let me know. But let's, for today, okay, so stuff after the midterm, these are the 2 assignments we did last week in WebEx. So those are due today, or by midnight today. So example 4, 5, and the drug production assignment are due today, and the videos for those are posted if you need to see anything again. This week we're going to do examples 4, 8, and 5, 4. Today is the last exercise in chapter 4, which is 4, 8. Alright, so here's example 4.8. We can go ahead and open up the example 4.8 document. Okay. Alright, and then the first one you'll need is the hospital DEA Excel file. We can open that up. Okay, so example 4.8 is using this concept called data envelopment analysis. Okay, and so the exercise we're going to do I think we're doing 4 separate problems, but they're all pretty short. And so the first one will be pretty quick, but we're going to do a few short assignments today. So the first one, let me just read what this concept is, and then we'll use it for some examples. So this is a concept or a term called data envelopment analysis. And so this is a method that can be used to determine whether a university, hospital, restaurant, etc., some other type of business like that is operating efficiently. So you kind of develop a benchmark. So it's used by inefficient organizations to be benchmark efficient and best practice organizations. And so you figure out what is the benchmark, and then see if the other firms or businesses are comparable with the benchmark. All right, so okay, so let me read the description for example 4.8, which is this DEA, the data envelopment analysis in the hospital industry. So here, consider a group of 3 hospitals. To simplify matters, assume that each hospital converts 2 inputs into 3 different outputs. All right, in real DEA, there are typically many more inputs and outputs, but we're going to make a simplified model, okay, so we can solve it. The 2 inputs to be used by each hospital are here. Input 1 is capital, which is hundreds of hospital beds. Okay, input 2 is labor, which is thousands of labor hours used in each of these hospitals. And then these are the 3 outputs. Output 1 is hundreds of patient days during the month for patients under age 14. The second output is the other age group. Hundreds of patient days during the month for patients between 14 and 65. And then output 3 is hundreds of patients during the month for patients over 65, so that's the Medicare age group. Okay, so the inputs and outputs for the hospitals are given in the table, which are also in the Excel file. So we're going to use this DEA analysis, or the DEA type of problem, to determine which of the hospitals, if any, are efficient by comparing them to each other. All right, so these are the outputs, or these are the inputs in terms of what we define for each hospital, and these are the outputs. So we're basically trying to see if the inputs turn into outputs, or is there some loss of efficiency going on before it turns into outputs. So let's look at the spreadsheet. Okay, there you see the same inputs that you saw in the table, and so again, these are the capital and labor for each hospital, and these are the outputs. Okay, in terms of how many patients they get through in each of the categories. So output 1 was the lower age group under 14. Output 2 was the majority of the population, which is ages 14 to 65. And output 3 was age 65 and over. Okay, so we're going to use this concept to determine which of these hospitals, if any, is efficient. Alright, so there's an optional video if you want to take a look at this 5-minute video that explains a little bit more on the concept of data envelopment analysis. So take a look at that if you have some free time. Okay, let's start the analysis or the example. So step 1 is what we normally do is define the inputs decision variables I don't think we have any constraints in this because it's a different type of problem, but we have inputs, we have decision variables, and we have, or actually we don't have decision variables, we have inputs and we have an objective. So let's go to the spreadsheet. Alright, so the inputs, well, we have inputs here. So the inputs are essentially the inputs and the outputs. So what we need to color light blue are the input range here. In the output range. So color the numbers, just the raw numbers for the inputs, and the outputs, those are our inputs for this model. So those are the light blue areas. Okay, so we do have to use solver to decide something, and what we're deciding is basically the unit costs of the inputs and also the unit prices of the outputs. So that means that this area, B10 to C10, color that light red for the decision variable range. And also this area, which is looks like F10 to H10, also color that light red for the decision variable range. So solver's going to figure out those optimal numbers. Okay, and it says maximize the selected hospital's output value, so that's our objective, to maximize that. And so that means that cell B22 is the objective. You can color that the light, or the highlight yellow color. Okay, so there's our objective. Alright, so we're trying to develop a benchmark, and the benchmark we'll talk about is going to be 1. So the benchmark is going to be 1, which means 100% efficient. Alright, so we're gonna set up the model like this, and so that means when we do the solver, that any hospital that gives us an output or an objective that's less than 1 is going to be inefficient, and if they are 1 exactly, the highest they can get is 1. So if the hospital that we do comes out to 1, that means they're 100% efficient. If they're anything under 1, then that means there's some inefficiencies that we've found. Okay. Okay, so also we do have some constraints in that the input costs have to have some constraint to the output values. And so we're going to say that the input costs have to be greater than or equal to the output values. So that means simply that outputs can't come out of nowhere. They have to come from the inputs. And so all outputs have to come from the inputs. So make this constraint noted here. Starting in C14, put a greater than or equal to. Alright, so in the range C14 to C16, put greater than or equal to. So note that all the input costs for each hospital have to be greater than or equal to the output value. Alright, so that's one of the constraints. And then also, we're gonna normalize the constraint on the selected hospital input cost to be 1, and that'll help us determine the benchmark, which is that if it turns out to be 1, then it's 100% efficient. So right here, where it says selected hostile input cost, we're going to make that equal to 1 to simplify the model as a benchmark. So that means in D19, just put a 1. Alright, so here we go. The inputs and the outputs are colored light blue. We're going to decide, solver's going to decide the unit cost of inputs and the unit prices of outputs. Make sure you put in this constraint here to show that the input costs have to be greater than or equal to the output values. Okay, we're going to constrain, to simplify the model, the selected hostile input cost is going to be equal to 1, and then we're going to maximize the output value, and if it comes out to 1, it's 100% efficient. If it's not, if it's less than 1, then it's inefficient. Alright, back to this document. Okay, so step 2 is range names, and after doing this a few times, I decided it's easier not to make range names for this one, and the reason is because we're going to kind of repeat the analysis multiple times, and so therefore if you make range names and you try to do it with a different example, then the range names have to be redefined, and so we're going to skip the range names because I think it's easier to do the extensions. We're going to do this exercise, I think 4 times. And so I think it's easier just to skip the range names because given that we have to do the example with some other problems, redefining the range names becomes a little cumbersome. So let's skip to step 2 for now. Alright, so you can certainly do it. I mean, you can certainly define range names. It's not gonna hurt your problem, but then you got to redefine them for the other parts, which becomes a little tedious. So I think let's move on to step 3. Alright, step 3 is easy. Just put in any numbers into the decision variable range. So in the unit cost of inputs and unit prices of outputs, let's just put in 1 for now. Alright, so just put a 1 into all of the light red cells. So here. Alright, so I just put in 1s in there, and I put in 1s for here. Okay, so the solver's going to figure out those optimal numbers later. So just put any values, or put 1s in the light red cells. Alright, so step 4 is to put this sum product formula into cell B14. Okay, so go to cell B14. And put it in this formula. So we didn't define the range names because I think it makes the next problem a little easier to not redefine the range names. So just put in this formula in B14 equals. Sum product. B10 to C10, and then comma, B6 to C6. Okay, so again, equals sum product, B10 to C10, and then comma B6 to C6. So make sure you get those two ranges, and there should be the same, so all the sum product functions have to have the same range in the two values. So see how there's two cells going across the row in both. Alright, so we're going to have the sum product of 5 times 1 plus 14 times 1, which is going to be 14 plus 5, so it should be 19. Okay, and then if you got this formula equals sum product B10 to C10, comma B6 to C6, just grab the bottom right corner and drag it down to cover hospital 2 and hospital 3 like this. Oh, okay. Alright, so that, we need to, I need to put in dollar signs, so let's go back to this one. Okay, so I failed, we're supposed to put in the dollar signs because we want to keep the unit cost of inputs the same, but we want it to go down to the different hospitals. So that means that the blue range, we need dollar signs in front of that. So just put, see how our formula says B10 to C10, comma B6 to C6. Change the B's and the C's for the 10s to have dollar signs like this. Alright, so that's what we want. We want, to say equals sum product, dollar sign B, dollar sign 10, so dollar sign C, dollar sign 10, and then comma, B6 to C6. So that's what it should say, right until B14. Alright, now we can grab the bottom right corner of B14 and drag it down to get the other two hospitals just like this. Okay, so if we got that, we can just get the rest of step 4, which is to do the output value. So go over here to D14, and this is going to be equal to the sum product of, let's see, F10 to H10, comma, and then F6 to H6, alright, but we also need to put dollar signs in front of the blue cells, because those are going to be locked, but the hospital should be able to go down the column. Okay, so put dollar signs in front of F10 and H10. Alright, so in D14, there's your full formula equals sum product dollar sign F, dollar sign 10 to dollar sign H, dollar sign 10, and then comma, F6 to H6. Alright, and then if you got that, grab the bottom right corner of D14 and drag it down to hospital 2 and hospital 3 in the D column. Okay, so what we've done is we've calculated the input cost based on the number of inputs we use for the hospitals. So if we use this many inputs of input 1, then it costs this times this. And then this is the cost of input 2 for hospital 1, this times this, and then the same for the outputs. So we've summed up the cost of the inputs based on how many inputs we use, and we've summed up the cost of the outputs based on how many outputs we use for all 3 hospitals. All right, so that was kind of a long step. Did everybody get those formulas for the input cost and the output values? Everybody follow along here? All right, sounds like we can go on to step 5. All right, so let's use the VLOOKUP function in cell D19. All right. Okay, back to the model. Okay, so in D19, type in this formula equals. The VLOOKUP function, remember we used this for the that's the quantity discount term, remember the Sam's bookstore? Okay, so the VLOOKUP, and then in the argument, okay, V3, comma, A14 to B16, and then comma 2. Okay, so again, here's the formula in cell D19 equals VLOOKUP. And then in the parentheses, V3, comma, A14 to B16, and then comma 2. So what this is going to do is it's going to find the hospital, which right now is 1, and then go to this range and find 1, and then report the argument for number 2, for column 2. So it's going to find the 1, here's the 1, and then give us the 19 for column 2. So that's what we're telling it to do, so it should give you a 19 here. Okay, hopefully that works. And then we're going to use another VLOOKUP for the objective. So in B22 in the objective, go back to there. All right, so in B22 equals VLOOKUP. And then again, B3, comma, and then A14 to B16. And then comma 4. All right, so there's your full formula in B22 is equals VLOOKUP, B3, comma, A14 to B16, comma 4. So what's going to happen here is the VLOOKUP is going to find the 1 and go down here and match the 1 and then report the argument in column 4. So it's going to find the 1 and report 29, right? So it should give you a 29 there. Okay. So did we get the VLOOKUP there in B19 and the other VLOOKUP here in B22? So make sure you got those two, because the next thing we got to do is do the solver. Okay, so we're going to use solver to determine if the hospitals are efficient. So let's go back to the model and let's run the solver. All right, so data tab and then let's run the solver, hit solver. Okay, and let's specify our problem. So the objective is the highlight yellow cell. Okay, so the objective is B22. We want to maximize that, so you can leave that as maximized. We're going to change the two red areas. So hit this button and choose B10 to C10 and then comma. F10 to H10, so both of the red decision variable ranges with a comma. Alright, so B10 to C10, comma F10 to H10. Okay, and we do have a couple constraints, so we need to specify the input cost constraint. So hit where it says subject to the constraints, hit add. And we're going to specify this one exactly like this. So input costs got to be greater than or equal to the output value. So the cell reference, hit the button, is B14 to B16. Choose that. And then we're going to flip the sign around to be greater than. And then the constraint is hit this button and choose D14 to D16. Yeah. So there's your constraint. B14 to B16 has got to be greater than or equal to D14 to D16 and hit OK. Alright, and we have one more constraint, which it says right there, the constraint on selected hospital's input costs. We're going to make it equal to 1 so we can understand the efficiencies of the hospital. So let's do one more constraint. The cell reference is B19, and choose that. And we're going to say that's got to be equal to 1. So make this in the middle. This is going to be equals. And we can choose the number here, which is D19. And so for this one, B19 equals D19. So we're going to constrain the hospital input cost to be 1. Okay? And then this should be checked. Make unconstrained variables non-negative, and then this solving method should be simplex LP. Alright, so let's double check the parameters. So the objective is E22, we're going to maximize that. We're changing B10 to C10, comma F10 to H10. Our constraints, B14 to B16 got to be greater than or equal to D14 to D16. D19's got to equal D19. And this is checked, and this method should be simplex LP. So everyone good? Anyone need any of the solver parameters repeated? Okay, so let's solve and see what happens. Alright, so you should get that hospital 1, its max value is 1, which means that hospital 1 is 100% efficient. Okay, do we get that? For the output value for hospital 1 after the solver is run? Okay.
What was the last constraint for the solver? Because mine failed. Like it said that it wasn't.
Here are the parameters. So look at double check those there.
Can't really see. What's the second one?
Which one is the constraint?
Yeah, the constraint. It's like
it's D19 equals D19.
D19 equals. And it's a simplex. What's the objective?
The objective is B22. Just the yellow cell.
Alright, I got 0.
You have 0 is your output value? Okay, so that's you should have gotten 1. So I can look, if you want to post yours to the Blackboard, I can look at it. Oh, so we got a couple zeros. So let's see if we can figure out the problem here. Alright, so if you got 0, looks like a couple of you did. You can go ahead and post your Excel file in example 4.8, and I'll take a look at it in a minute and see if I can diagnose the problem. So if you got 1, that's correct, because hospital 1 should be 100% efficient. So let's go back to the steps. Alright, so all we're going to do here is run the solver for hospital 2 and hospital 3. So this step is very easy because we've solved them all correctly. So just go back to the Excel file. Okay, so to check if hospital 2 is efficient, just see where it says selected hospital, just change that to 2. Alright, that's it. Just put a 2 in B3. And we should have set up the model correctly that that's going to just do it for hospital 2, given the VLOOKUPs and things. So put a 2 in B3 and then run the solver again for hospital 2. Okay, and don't change anything, just hit solve. It looks like we should get for hospital 2. It's only about 77% efficient, so we get 0.773.
For some reason I still get 0.
Alright, so we get 0.773 for hospital 2, and that means the hospital 2 is only 77.3 efficient on a scale of 0 to 1, and so in other words, it's inefficient. Okay, so hopefully some of us got that. Let me see if you guys put your file up there. So that part looks good. Let's look at the VLOOKUP part. Okay, so the rest is, your model is set up correctly, Ariana, but let me check your solver. Alright, so we got B23, we got maximized, let's do B10 to C10, and F10 to H10. Yeah, when I ran the solver, it came out okay, so, yeah, so it looks like you have it correctly, and when I ran the solver with the same parameters, it worked. So just double check the solver parameters for yours, and it looks like it worked fine, because I did it and I got a 1.
Could it be because I'm on the Mac?
It could be, but it still should work. So
When I press for solver results, it gives me 2 options to keep the solver solution or restore original values. Do I just keep the solver solution?
Yeah, do that.
It still gives me 0 for some reason.
Me too.
Using a Mac too?
Yeah.
I mean, did the solver parameters look just like this? Because I double checked the spreadsheet looks fine, and there's nothing wrong with that. So it has to be something with the solver, but Okay.
The solver looks the same.
It's given you a 0. Because I mean, when you gave it to me, it was a 0, but then I ran it again, and it gave me the 1. Like well, here, let me repost this one that I got to yours, and it looks like it works fine. All right, so see if that one works, because it looks fine to me. Okay, so that were you able to get yours to work? Huh?
No. Mine still produces 0. Maybe even change like the hospital selection and just comes out as 0.
Yeah, that's weird because it looks there's not that much going on in this model. It looks like it at least hers was it looked fine. I mean,
Yeah, no, mine's looks the same way as hers, and mine still produces 0.
I think it's just a Mac problem because when I download the document and I press solver again, it just goes back to 0.
yeah. Well,
I just wanted to jump in. I'm on Windows, so I'm having the same issue.
oh, okay. Well, do you want to post yours? And I'll look at. I mean,
Sure, yeah.
yeah, post yours to the discussion forum. We'll see what we can figure out here. Did some? It looks like some people are getting it correct, right? So did some of you got the 1 and the 0.773 for hospital 2? Yeah. Okay. So. Alright, so we'll do this. I'll check yours in a second. So if you want to check hospital 3, all you have to do is see where it says selected hospital, change that to a 3 in B3. Alright, so if you've got this, just put a 3 there in B3 and then run the solver again to see if hospital 3 is efficient. Alright, so run it again for hospital 3 and hit solve. And you should get that hospital 3 is efficient. So hospital 1 and hospital 3 were efficient. Hospital 2 was not. So this is what you should get for hospital 3 if you rerun the solver. Okay, great. So at least it looks like a lot of people it's working. So it worked for Dominic, it worked for Taylor. Alright, so just, let me see what, okay, so this one I see the problem because, whose is this? This is, Andrew?
This is mine, yeah.
Yeah. So yours, oops. It should say that D19 equals D19. Alright, so if you just switch this to that, it should work. So let me try it.
That works for me, so.
Yeah, so that was your problem. Now the other one.
I must have just misread it, that's my bad.
Yeah, okay, so you're good. Now, Dom, or who's the one, who else is getting zero? So I looked at.
That was me.
Okay, do you want to post yours?
Yeah, I'm doing it.
Alright. Yeah, so I looked at Ariana's and yours looked fine, so I'm not sure what the problem is. But maybe it's a Mac issue that I'll confirm with Alright, here we go. Let's see. Yeah, see, I ran yours again and it works, so I don't know.
My solver's broken.
It has something to do with the solver. I don't know what. When I solve it, it works fine, and you're choosing the keep solver solution, right? Is this hitting okay?
Yeah.
Yeah, I got a one, and let's see. I think it worked for the other ones too. Yeah, yours is fine, and so both of yours are working fine. It's just something's wrong with your solver or something, but you've done it correctly. Yeah. So just so yours is fine. Alright. I think we've done up to step 8. Alright, so we found that hospital 1 was efficient, hospital 2 was not, and hospital 3 was efficient, right? And so let me find my spreadsheet again. Alright, so the next thing we're going to do, hopefully, is do some extensions or some additional problems with the same type of methodology. And so there's some other Excel files. There's 3 of them we can do. They shouldn't take too long, but if we don't have time, we don't have to do them all. And so let's first do the one, problem 41. So I think I have a description over here. Alright, so we're going to do the same for this one, this problem number 41. So the Salem Board of Education wants to evaluate the efficiency of the town's 4 elementary schools. The 3 outputs of the school are output 1 is the average reading score, output 2 is the average math score, and output 3 is the average self-esteem score. And then the inputs are, input 1 is the average education level of mothers, defined by highest grade completed, 12 is high school, 6 is college graduate, and so on, so the number of total years. Input 3 Okay, input 2, I went down to the wrong problem. Input 2 is number of parent visits to school per child, and input 3 is the teacher to student ratio. So these are the inputs, these are the outputs, and we're going to evaluate using this file if any, or all, or whatever combination of the 4 schools are efficient or inefficient. So let's go back to the Blackboard page. Alright, you'll see that there's some other Excel files that I have here in the example 4.8. So let's open up TO4_41. And so for the couple of you that were getting 0 with your solver, just kind of keep doing the analysis, and if it gives you 0, that's fine, but you'll still get full credit because it worked on my solver, and so just repeat the steps. If you get 0, just post it anyways, but don't worry about it. They look fine to me. So if you get 0, just go with it. Okay. All right. Yeah. Okay. So let's open up this one, 41. Alright, so the point of these additional problems is to show that we can use what we've already set up and kind of look at another problem pretty quickly. And so here we got inputs and we got outputs. So what we're going to do is, let's see, let's go back to the original model. Alright, and let's open up a separate tab, so like this, just hit the little plus sign. Alright, so what we're going to do is we're going to copy and paste what we just did on this model, put it into the other sheet, and then we're going to redo the analysis for this one, and all we have to do is change a few things. So if you want to see where it says sheet 2, or sheet 1, let's call that hospitals, or hospital, whatever. Okay, let's copy and paste all of this and put it into the hospital one, and then we're going to use the active model for the schools. Okay, so if you choose this, like just hit the top left corner like this. And if you hit that arrow, it should select everything. Okay, so everything is selected, and just hit to copy, Control C. All right, and then go to the hospital separate tab that we set up here, and just choose that top right corner, and to paste it, just hit Control V. All right, so you're just putting your hospital work that you just did into a separate tab. All right, so we can use the active model to do the new problem. All right, so there's your hospital stuff, and then go back to this model, and let's do the analysis for the schools into the active model. All right, so does everyone see what I did? Just copy and paste the completed hospital work into this tab, and then let's go back to this one and do the analysis again for the schools for problem 41. All right, and then when we're done, we're going to have a separate tab for each of the problems we do. So we have a hospital one, we have a school one. There's some other ones if we have time. All right, so because this is going to be for checking for schools, then we're going to use the replace feature to change the word hospital to the word school, right? Because this is a school one. So if you get Control F, that should take you to this find and replace feature. And if you click on replace, and if you under where it says find what, let's replace the word hospital. Let's replace that with the word school. Okay? So find what hospital, replace with school, and if you hit the replace all button, that should do what we're trying to do, and replace all the words hospital with instead the word school. Okay? Does that work? Yes. So let's hit to do the find function, hit Control F. It might be a different shortcut in your Mac, but you got to get to the find and replace option. All right. So once you get to the find and replace box, click on replace, and where it says find what, just type in hospital, and where it says replace with, type in school, and then hit the replace all button. Okay, did it work? Okay, great. So now what we need to do is put the data from that separate Excel file into this one and make a few adjustments, and then we'll rerun the solver to determine if the schools are efficient or not. All right, it looks like this is a different one. This is for the banks, which is a different question. So I guess let's go. Let me look at the data files again on Blackboard. Yeah, so they changed the order of the questions, I guess, in the older version. So the one you want is the 42 file. So it's on Blackboard under this section. Under example 4.8, the data we want for this question for the schools is the P0442. So open this one. So you should see this data. Alright, we'll get to the other one in a second, but here's what we want. So we want to put this stuff into the current active model. So you have 3 inputs, 3 outputs, and 4 schools. Alright, so basically we need to add an input, we need to add a school. Okay, so right here in D5, just type in input 3. And right here in A9, just type in school 4. So we're setting up the extra data we need. Alright, so this is school 4 in A9. Alright, and then what we're going to do is copy and paste that data into this file and then run the solver again. So back to this one. Alright, so if you found the P0442 one with the Salem Board of Education, let's copy and paste the inputs and copy and paste the outputs into the active model. So here we go. On this spreadsheet, if you select B4 to D7 and copy it, Control C. And then here in the active model, if you just go to B6 and hit Control V and paste it. Alright, so that should have pasted the inputs from the school model into this current active model. And we do the same for the outputs. Okay, so select from the Salem Board of Education file, select E4 to G7 and copy that part, Control C. And then just choose F6 and paste it, Control V. Alright, so you should have that, these are the inputs 1, 2, and 3 for the 4 schools. And you should have that these are the outputs, oh, we also need to put school 4 here. Yeah, I'll do it. Okay, so what we did is we added a third input, and we added a fourth school. So make sure first we have input 3 here, and make sure that you have school 4 here, and school 4 here. And then go to the Salem Board of Education file, and what you want to do is copy and paste the inputs into the inputs, and copy and paste the outputs into the outputs. So first, D4 to D7, copy that, Control C. And then, starting in cell D6, just hit Control V to paste it. So you're pasting that table right here. And then do the same for the outputs, back to the education file. Copy that, D4 to G7, Control C, and then go back to the active model. And select F6 and then paste it, Control V. So what the data from that other file, you put here in the inputs and the outputs, so it should look like this. Alright, so check that your model tab looks like this, or just if you can also just type in, they're just numbers, so you can just type them in too. So you need those values for the inputs, and then these values for the outputs. Okay, so everybody following along here for the new information for the schools into the current active model? Alright, and then you can see that because we have a third input, we're also going to have another unit cost of inputs. So D10, let's make that the light red color. And then just put any number in there for now. In D10, I'll put a 1 in. Alright, so add that third input right there. And then you have the same over here, so this should be the same. Alright, and then down here where it says constraints that input cost must cover, we need to add the fourth school. Okay, and I think we need to slightly modify the formula in D14. Okay, so see, we need to add the third input. So in D14, you need to modify your formula to say $B, $10 to $D, $10, and then comma, B6 to D6. Alright, so in cell B14, there's your modified formula, equals sum product, $B, $10 to $D, $10, and then comma, B6 to D6. Alright, see how it includes the third input? So hit enter, and then you can take that formula and grab the bottom right corner and apply the new formula to schools 2, 3, and 4 like this.
So like, it's not work.
Doesn't work?
Yeah.
Okay, so let's look at let's look at the first one. So if you click on the formula you have in B14, alright, does it match up like this? Does it say equals sum product?
Yes.
$D, $10, to $D, $10, then comma D6 to D6? So when you select it, you should see that this range is selected and then this one.
Oh, I see. Thank you a lot.
You're welcome. Okay, so if we got that for the input cost, I think the output values, the formula is correct. Yeah, it is, because we have the same number of outputs that we had before. So for this one, just drag this down. Alright, so the same formula you had in D14, just grab the bottom right corner and drag that down, like this. Alright, so we got that for all the schools. If you want, you can put another greater than or equal to here for the fourth school. Alright, and then for the selected school input cost, if you go to B19, the only thing we have to do here is expand the range to include the fourth school. So it should say equals VLOOKUP B3, A14 to B17. And everything else is the same. So your formula, your modified formula in, what is it? B19 is equals VLOOKUP B3, comma A14 to B17, comma 2. Alright, so the same thing, but you added the extra school. And then finally in the objective cell in equals VLOOKUP D3, and it should say A14 to D17. Alright, so equals, here's D22, so this is equal to VLOOKUP D3, A14 to D17, then comma 4. So we just expanded the range to include school 4, and hit enter. Alright, so we've modified the model slightly to include the information for the schools. Alright, so the next step is to run the solver again, and determine if the schools are efficient or inefficient. Everybody got the modified model so far? Alright, so if we got this, we can, here's this one. Alright, so it depends on what this number is too. If your school is different from 3, then it might be a different number. Yeah, so for some reason mine's on school 3, so if yours is school 1, you might get what you said. Maybe not. I don't know. Well, let's if the formula is right, then the solver should fix it. So let's try determining if school. So first up, go up here, and we're gonna start with school 1. So in B3, just change that to a 1. Let's start with school 1 and check and see if that's efficient or inefficient. So now let's run the solver, data solver. Alright, and you should have what you had before, and so we need to change a few things, but it's pretty much the same. So the objective is the same, maximize is correct. Now the only thing we need to add here in the changing variable cells is that we have a fourth school, right? Or, a third input. So right here, it needs to say B10 to D10. Okay, so I made that slight adjustment there, where it should now say D10 to D10, comma F10 to H10. So make sure you change that letter because you have to include the third input. So the changing variable cells is now D10 to D10, comma F10 to H10. And the constraint for the input cost must cover output values, that needs to include the fourth school. So click on it and hit change. Alright, and the only thing you have to do is make it go to the next school 4. So it should say B14 to B17. And the constraint should say B14 to B17. Okay, so make that slight adjustment on your constraint, where now it should say B14 to B17 is greater than or equal to B14 to B17, and that's going to include the fourth school. Okay, and everything else is the same, so just when you open up the solver, make those 2 adjustments where you add the extra letter by changing variable cells, and you add the extra letter into that one constraint. So your solver parameter should look just like this. All right, let's solve this and see what happens. Okay, so if you got this to work, then we should get that school 1 is 100% efficient. All right, did we get that solution? Okay, good. All right, let's check school 2, school 3, and school 4, and this is easy. Just change the number when it says selected school, change that to 2, and run the solver again. All right, so in B3, that's now a 2, and just rerun the solver and hit solve. All right, looks like we get the school 2 is also efficient. Okay, let's check for school 3. So again, this part's easy. Just change the selected school to 3. And run the solver again and hit solve, and let's see what we get. Well, looks like if we're doing this correctly, the school 3 is also efficient. All right, then let's finally check school 4. All right, so change the selected school, B3, change that to a 4, and let's run the solver again to check school 4 efficiency. All right, so it looks like we got one of the schools, school 4 is not efficient, only about 95% efficient. So looks like we should get 0.949 for school 4. Okay, which would mean that school 4 is inefficient. All right, did we get that for schools 1, 2, 3, and 4? All right, so we're almost out of time here. So I think let's go back to the Okay, so I think what I'm going to do is we'll have time to do 41, 42, and 43. Is maybe I'll make these extra credits. So let's including this one. So let me type in what I think we're going to do. Okay, so I'll have to send an email explaining this, but I think we'll only have to, for full credit for this one, since there were some issues. To get credit, for example, 4.8. If you've done what we've done so far, then that's more than enough. But you have to at least do the hospital part. So the original file, the hospital file, the completed Excel file has to go here. For example, 4.8. Okay, so make sure you have at least the hospital part done for the DEA analysis, for example, 4.8. And then I think I'm going to make the other, if you want to get an extra credit opportunity for anything you missed in the past, then you can do the rest of the problems. So again, I'll send an email explaining this, but the problems 41, 42, and 43, if you submit those together correctly, that'll count as, if you miss any past assignments, this will count as a bonus assignment. So if you've done every single assignment, then you don't have to do this for extra credit, but if you want to make up for a missed assignment, then you can finish the rest of them. And so what you have to do is kind of what we did for the school one, is open up the file and answer the question for the other one. So you got the school one we just did. And the rest of them are explained on, if you look at the old textbook I put on, the PDF. Okay, so under the syllabus tab, where it says Practical Management Science 3rd Edition PDF, on page 190 here, this explains the number 41 and the Pine Valley Bank one, and then also there's a police department one. So you can look at those, and then the data files are here. Okay, the 3 data files are there. So you should have enough information if you want to do those for extra credit. I'll send an email to the class explaining what I just said. But to summarize, okay, so example 4, 5, and the drug production assignment are due today. Just for full credit for example 4.8, the hospital part is due next Tuesday. If you want to do the rest of the assignment for the 3 bonus problems, that'll count as an extra credit. And we'll do example 5.4 on Thursday. Okay, so sorry went over a little bit, but you have an extra credit opportunity if you want to do that, and I'll explain that in an email, but we've gone over time, so we'll stop here for today, and I'll see everyone on Thursday.
Hi, Professor.
Yes.
For the extra credit is only added to the assignment or also added to the main exam?
Oh, so it's like if you've missed any assignments, it'll count as a makeup assignment.
Okay, so did we already finish the 41, 42?
Oh, you've already done 42?
No, I mean like you used the 42 before on the class, right?
Yeah. So I think, well, let me see what. So they just switched the problems around in the older version. So let me explain what. Okay, so for problem 41, the data file you want to use is the one we just did, which is 42, the 42 one, and then for the other one, 42, that's actually file 41 because they switched them. So if you look at 41, that should be the one for the banks. Okay, that's that one. And then the other one, 43, is for the police department one, and that file is the last one, which is 43. So, okay, so this one is actually for 40. So for problem 41, use file 42. For
Okay.
problem 42, use file 41, and then for problem 43, use file 43. So just for whatever reason, these two were switched to the newer version. So the for question 41, use 42, and for question 42, use 41, and for question 43, use 43.
Okay, thank you a lot.
Okay, yeah, makes sense?
Yeah. Thank you. Have a great one.
Okay, you too.